Okay, mock exam for lines. Number one, the gradient of several lines are as follows. A, B, C, D, F, G, H, I, H are the names of the lines. The gradients are -3, -5/2, etc. Find two pairs of lines that are parallel to each other. So what they want here is they want to make sure that you, the student, knows that if two gradients are the same, then that means that the lines are parallel to each other. Okay, so let's see if we can find gradients that are the same. And the only challenge here is that sometimes they write them as decimals, sometimes they write them as fractions, sometimes they write them as unreduced fractions. Okay, so to see if they're all the same, one of the ways you could make sure that they're all the same is to change all of them to a decimal. So for example, anyone that's not a decimal like this one, -5/2, you can just change to a decimal by dividing it out. I get 2.5. So this one is actually -2.5. 1/3, for example, is equal to 0.333. Okay, so 0.333. And then 3 divided by 6 is 0.5. -2 divided by 5 is 0.4. Okay. -5 divided by 2 is equal to -2.5 also. And there's 0.4. Okay, so let's see. How many matches do we have? How many have the same gradient? So we have this one, -5.2, and this one, -5.2. So these are the same. They're both they have the same gradient, so they're parallel. Anything else that's the same? Oh, look, there's 2.5s. Okay, so those two are the two pairs of lines that are parallel to each other. So we'll put B and G. And then what else do we have? We have D and E. Okay, all right. Find any two pairs of lines that are right angles to each other. Okay, so this is testing to see if you know that lines that are right angles to each other are actually perpendicular. And perpendicular lines have gradients that are inverse negatives of each other, negative inverses of each other. So for example, if you have a gradient that is 2, if you want to find the gradient that's perpendicular to that, you would invert it and then make it negative. Okay, so let's see if we have any of those pairs. And like for this comparison, it's kind of better to have fractions instead of decimals, because decimals sometimes it's hard to see what the inverse is. So let's see. Let's convert these to fractions, and you can do that with the calculator. You could turn it into mode, and then let's put don't remember what it's called. Here you go, answers. You put answers into fraction. Okay, and then we quit. And so if we put any of these numbers in to the calculator, it will give us a fraction, except for that one because it's just a number. But for example, let's put in 0.5. And it gives us that 0.5 is actually 1/2. Okay, so this is 1/2. That's 1/3. 3/6. If we give it 3/6, it will reduce it for us. It will also say that 3/6 is also 1/2. -2/5. Okay, that's already in a fraction. -5/2 is also a fraction. What about 0.4? What is 0.4 in terms of a fraction? It's 2/5. Okay, so now do we have everything in terms of fractions? I think we do. Okay, so now we're going to say, okay, where are the perpendicular pairs? So like for example, for -3. For -3, we're looking for the negative inverse of that, which would be 1/3. Oh, there it is. So there's a pair. What about negative 5 over 2? Do we have a positive 2 over 5? No, we don't. We have a negative 2 over 5, so there's no negative inverse of b. What about c? We already found. What about d? It's 0.5, which is 1/2. Is there a negative 2 in here? No, there's not. So there's none for that, none for that. What about negative 0.4, which is negative 2 over 5? Is there a positive 5 over 2? No, there's not. So last of all, there's a 0.4, which is 2 over 5. It's a positive 2 over 5, so I'm looking for the negative inverse, which would be negative 5 over 2. Is there a negative 5 over 2? Yeah, there is. In fact, there's like two of them, isn't there? Negative 5 over 2, there's this one, and there's also this one. How interesting. Okay, so one of the pairs is A and C. Okay, and then another pair would be B and H, and another possible one would be B. I'm sorry, G and H. G and H. So there's three possible answers. Okay, so let's find any two pairs. So you don't need to answer all three, you just need two of the three. Okay, next question. The following diagram shows 6 lines with equations of the form y equals mx plus c. So we have several lines here. They're all diagonal lines. Some of them grow and some of them go down. That's a hint. If we want to figure out which ones are positive slopes, it's the ones that look like the green line where it goes up. And if we want to find the ones that are negative slopes, it's the red ones that go down. And this is important because if you look down here, what we're looking to do here is we're trying to find lines which satisfy the conditions m is positive, c is positive, m is negative, c is positive, etc. And what does it mean by that? Well, when you have a line in this form, y equals mx plus c, which is called gradient intercept form, m happens to be the gradient or slope, and c happens to be the y-intercept. The y-intercept is the point on the vertical axis where it crosses the line. So the gradient can be a positive number or a negative number. The c value, or the y-intercept, can be a positive number or a negative number. Now, what does it look like when the gradient is positive? Well, it looks like the green line there, sloping up. Okay, so which ones are positive slope? Let's see. This one, m is growing, right? What about this one here, too? M is growing, or the gradient is positive. And this one, the gradient is positive. All the others look like the gradient is negative. So this one, gradient is negative. This one, gradient is negative. This one, gradient is negative. And this one, okay, now that's it, I think, okay? So now what about the c value? When is the c positive? Well, the c is positive whenever it crosses the vertical axis above the origin. So like here, the c value is positive. Where else? Here the c is positive. Okay. What about where is the c negative? Well, here the c value is negative. And here the c value is negative. Okay. And what about these other two? Well, like here, the c value is actually 0, right? And this one too, the c value is 0. Okay, now that we've described m and c in terms of is it positive, 0, or negative for all 6 of these, now we can go down and answer the questions very easily. So the first one says, which line has slope gradient positive and y-intercept positive? So that we're looking for one that has both green. That would be this one here, right? So L5. So line L5 has both positive gradient and positive y-intercept. What about m is negative and c is positive? M is negative and c is positive. That's this one here, L4, right? because in this one, m is negative and c is positive. Now the next one says m is negative and c is negative. Both are negative, so that would be both red. Okay, that's this one here. That's L1, right? Okay. Last one, m is positive and c is negative. M is positive in green, c is negative. So that's this one here, which is L3. Okay? And the other two did not fall into any category as c is equal to 0. All right. Moving on to number 3. A student has drawn two straight line graphs, L1 and L2, and marked in the angle between them as a right angle as shown below. The student has drawn one of the lines incorrectly. Okay, and we don't know which one is incorrect yet. We're going to find that out later. They're going to guide us through the problem, so don't worry. Consider L1 with the equation y equals 2x plus 2, and L2 with the equation y equals negative 1/4 x plus 1. One thing I notice immediately about these equations is they're in the form y equals mx plus c. So when they're in y equals mx plus c, you can immediately see the gradient from looking at the equations, and you can also see the y-intercept. Let's see what they're going to ask us. Write down the gradients of L1 and L2 using the given equations. Okay, so immediately they're saying, tell me what the gradients is for each. And we know that the gradient is the number that's multiplied times x as long as the left side is y by itself. So there's m and there's m. So we're going to write those two down. So L1, the gradient is equal to 2, and L2, the gradient is equal to negative 1/4. Okay, that's all they were asking. Which of the two lines has the student drawn incorrectly? Okay, just based on the fact that the gradient of L1 is 2 and the gradient of L2 is negative 1/4, we can start to suspect that there's something wrong, because if we look at the graph, they are perpendicular to each other. But as we saw in the last problem, if one of the gradients is 2 and the other is negative 1/4, which are not negative reciprocals, then we know that they can't be perpendicular. So we know that one is wrong, but which one is wrong? Well, we can figure that out by using the definition of a gradient, which is like if the gradient is 2, that means that we should see a line that has a rise of 2 over a run of 1. Okay, and it's L1. So this is L1 here. Let's check the gradient for this line. The rise is plus 2, and the run is plus 1. So it's 2 divided by 1, and hey, what do you know? That's okay. Okay, so this one is okay. What about L2? It has a gradient of negative 1 over 4. So that means the rise is negative 1, so meaning it goes down 1, and the run is positive 4, which means it goes across 4, and that would be negative 1/4. Okay. Now let's check out the drawing here. We're going to draw a triangle using the whole number points, and we can see that the run here is 4, and the rise is 2, or actually it's negative 2 because it's going down. So negative 2 and plus 4. So the gradient of L2 in this picture is negative 2 over 4. And what we want it to be is negative 1 over 4. So we just discovered that L2 is the line that's drawn incorrectly. Okay? All right. How can you tell from the answer to part A that the angle between L1 and L2 should not be 90 degrees? Okay, well we can see that the gradient of one is 2 and the gradient of the other one is negative 1/4, and they are not negative reciprocals. So if they're not negative reciprocals, then the two lines should not be, or they shouldn't be parallel, right? So they are not negative reciprocals. Okay? D, draw the correct version of the incorrectly drawn line on the diagram. Okay, so let's see. If we're going to redraw this line, y equals negative 1/4 x plus 1, we know that the slope is wrong. What about the y-intercept? Did they draw the y-intercept correctly? Here they say the y-intercept is 1. so let's check it out. Okay, yeah, it is. It's correct. The y-intercept for the line 2 is going to the right point, but the slope is wrong. So let's redraw the slope, okay? Instead of having negative 2 over 4 for the slope triangle, we're going to do negative 1 over 4. So that would be this triangle instead. Okay, so it would be like this triangle instead. Okay, so negative 1 divided by negative 1 um, rise divided by plus 4 run. And so we can see that what we want to have is this line here. Okay, so that's our new line, which is correct. Okay, moving on to number 4. The equation of the line R1 is 2x plus y minus 8 equals 0, and the line R2 is perpendicular to R1. Calculate the gradient of R2. We don't even know the equation for R2, so we're going to have to use the fact that R1 has this equation. Now, can we just take the number that's multiplied times the x and assume that that is the gradient? Normally we can if it's gradient intercept form, which looks like this. Now, is this gradient intercept form? No, it's not, because y in gradient intercept form is all by itself on the left, and here we have y mixed up with everything else. So let's isolate the y and make R1 into gradient intercept form. The way we're going to do that is we're going to use algebra. And so the first step is we're going to subtract 2x from both sides. We're going to get the y by itself. And we're going to add 8 to both sides. Going to get the y by itself. So we're going to have y equals negative 2x plus 8. Okay? And here, it's in gradient intercept form, right? It matches that. So the m is the gradient. So the negative 2 is the gradient. You have to be careful. You need to say it's negative 2. Okay? So the m of R1 is equal to negative 2. Okay? Now, what about the m of R2? Well, we know that R2 is perpendicular to R1, although we don't know the equation to R2. So we could just take the negative reciprocal of minus 2 and say it's, positive 1/2, and the m of R2 is equal to positive 1/2. Okay, so that's the answer to 4a. What about 4b? The point of intersection of R1 and R2 is 4, k. Okay, and so we actually, let's see, I'm gonna just make a sketch of what this graph would look like. And this is not to get any numbers off it, just so that you can kind of have an idea of what it looks like. So the y-intercept is plus 8. Let's say that's plus 8. And then the slope is negative 2. Negative 2 slope would look kind of like that. It would be very steep going down. Okay? So if we look at this and we say, okay, what is the value when x equals 4, we don't know exactly where that is. Would that be maybe around 0? Or we'd have to draw a picture on graph paper to actually see that. And since there's no graph paper here, maybe we could do it with the calculator, okay? And basically, we need to find a point where these two lines intersect, and the R2 line is perpendicular to the R1 line. So it looks kind of like this. We just don't know where exactly this point 4 comma something is located. So, but all we need to do, since they told us that the x-coordinate of this intersection point is 4, let's just figure out what is the y value of line R1 when x equals 4. And since we know the equation for R1, we could just put it in the calculator. Remember what I said about whenever you have the equation to a line, even if you don't know what you're doing, go ahead and graph it, because it's going to tell you stuff that's going to be helpful. Okay, so we're going to clear that out, and then we're going to put in the equation negative 2x plus 8. Negative 2x plus 8. I'm going to graph it. Okay. Hey, it looks kind of like the thing we graphed there. Now, we need to find out what the y-coordinate is of when x equals 4. So first thing we could do is we could do a trace, and we could say, hey, I want to know what y is when x equals 4. Hey, what do you know? It's 0. Okay, what is another way we could figure that out? We could use table. We could do second table, and then we could look and we could say, okay, what about when x equals 4? What does y equal? Hey, it equals 0. So that's two ways to find out what k is when x equals 4 and it's 0. Okay, so the value of k is 0. All right, so actually my drawing happened to be right, but there's no way of knowing that it would have been like that. It was just a guess. What is the equation of R2? Okay, so now we know that the slope, the gradient for R2, we know is the negative reciprocal, we just put it up there, of the gradient of R1. Okay, so we know it's m equals 1/2. And what else do we know? We know that it goes through the point 4, 0. Okay, so with those two pieces of knowledge, we can figure out with algebra, or we can figure out using the calculator. So let's do algebra first. We know that the slope of the gradient for the equation for the line is going to be y equals mx plus c, and we know that the m value is 1/2. Okay, and we also know that one of the valid points is x equals 4, y equals 0. So we can plug in x equals 4 and y equals 0, and we should get a true equation. What we end up getting is 0 equals 1/2 times 4 is 2 plus c. So what does c have to equal to make this true? C has to be negative 2, and we can see that easily. If we subtract 2 from both sides, then we get negative 2 equals c. Okay, so actually this here is y equals 1/2 x minus 2. Okay, that is the correct equation. And there's another way we could figure that out. The other way you could figure that out is you could draw a little sketch, okay, and you know that one of the points is 4, 0, for example, okay? And then you know that the other point, one more point on the line you could find by making a little triangle with rise of 1 and run of 2. So you could make a triangle that is 2 to the right and 1 up. And you know that the second point here would be 6, 1, right? Because I add 2 to the x-coordinate, I add 1 to the y-coordinate, then I would get 6, 1. Now that I have two distinct points, I can use the len-reg function to find the equation of a line that goes through those 2 points. Okay, so the way I do that is I just use stat, edit, and then I'm going to go in here and I'm going to enter 2 points. The first point I'm going to enter 4, 0, and the second point I'm going to enter 6, 1. And I hope you've done enough of these problems that you know that 4, 0 goes across and 6, 1 goes across also. And then you can graph it if you want to. All right, no, you can't. You can't. We haven't gotten the equation for the line yet. So we go stat, calc, and we're going to go down to len-reg. And then we're going to use L1 and L2 because that's where we put our x-coordinate and y-coordinate. Make sure the frequency list is blank. And then you go down to calculate. And then it gives us the equation for the line, which is y equals 0.5x minus 2. Hey, what do you know? That's exactly what we got there. Okay? So y equals 0.5x plus 2. Now that we have the equation for the line, we could even graph it and make sure that it's right. And so we're going to put here 0.5 x plus 2, and then we'll graph the 2. And just don't worry if it doesn't look exactly perpendicular sometimes, because like what happens here is it's kind of the screen for the calculator is like wider than it is tall, so it doesn't look perpendicular, but in this case it is. Okay, so we can just kind of check to see if it's basically the right answer. And you know, one thing you could do is you could check to make sure that, hey,